let's use the precise definition to actually prove that a limit is what we think it is. So the example we're going to work with here is f of x equals 2x plus 1, and here's a graph of it. And we're going to think about the limit as x goes to 2 of f of x. Now you can see that for this graph, clearly it's 5, just based on our intuition of what the limit ought to mean. But let's use the precise definition of a limit to see how this how we can use this definition to sort of verify precisely that the limit is what we think it is. So to use this definition, we have to come up with, for every positive epsilon, we have to come up with a delta so that if x is delta close to a, and a is 2 in this case, then f of x is epsilon close to L, and L is 5 in this case. So we have to sort of answer infinitely many questions. For this epsilon, what delta works? And then for a different epsilon, smaller usually, what delta works? And so on. Well, we can't answer infinitely many questions in our lifetimes if we answer them one by one, because we just don't have time. So we'll have to, rather than picking values for epsilon, we will have to leave it as a variable and then come up with a delta that depends on epsilon. So really, delta is going to be a function of epsilon, and the hard part will be picking an appropriate function of epsilon so that this works out. So let's suppose that we have an epsilon. So suppose we have epsilon that's positive. Okay, so remember, here's our L value. Epsilon tells us how far away we're allowed to get from L. Now we need to pick a delta, and delta is going to be a function of epsilon. And at the very beginning here, it's hard to know what function of epsilon to choose. So if you don't have any intuition, then maybe just pick epsilon. Now probably what's going to happen is, as we try to verify this property here, this will not work, but hopefully seeing how exactly this fails to work will give us a better idea for what function of epsilon we should choose right here for delta. Okay, so we've chosen a delta. Now we can try to check this property. So now that we've chosen delta, let's suppose that we have an x value that is delta close to 2. And remember, delta is just epsilon. Okay, so we want to show that, f of x minus L, which is 5, is less than epsilon. Okay, so this is what we're hoping, right? We don't know if this is true. So what we need to do is write down this absolute value and see how big it is. So absolute value of f of x minus 5 is, well, we can use the formula for f of x. That's 2x plus, was it 1? Yes, plus 1. Okay, so there's f of x minus 5. So absolute value of 2x, let's see, minus 4. And, we don't really know anything about 2x minus 4, but up here we assumed that the absolute value of x minus 2 is less than delta. So how could we get the absolute value of x minus 2 to show up? Well, we could factor out this 2 right here. That would give us 2 times the absolute value of x minus 2. Okay, well, x minus 2, we know that that is less than or equal to, less than delta. And delta, remember, is epsilon. So we found that the absolute value of f of x minus 5 is less than 2 epsilon. Well, that isn't what we wanted, right? We wanted it to be less than epsilon. So this didn't quite work out. But this calculation does give us some insight into how to fix the problem. The problem is that right here, this delta, it was equal to epsilon, so this 2, right, this problematic 2 here, survived. But remember, for delta, we can go back and choose any function of epsilon. We didn't have to just choose delta equals epsilon. We could choose any function of epsilon. So we want to choose a function of epsilon that will cancel this 2 here. So why don't we choose 1/2 epsilon? So if delta is 1/2 epsilon, then we're supposing that absolute value of x minus 2 is less than delta, which is 1/2 epsilon. Okay, so now let's calculate what is the absolute value of f of x minus 5. Well, this whole calculation works the same way, except now when we plug in our function for delta, there's a 1/2 right here. That cancels the 2, and so we get epsilon. So we found that if absolute value of x minus 2 is less than 1/2 epsilon, then absolute value of f of x minus 5 is less than epsilon. So we were able to come up with, no matter what epsilon is, we were able to come up with a delta that works. And when I say it works, what I mean is this property is satisfied. So this proves, according to this definition of the limit, this proves that this limit really is 5.